Hey folks, welcome back to our channel. In this video, we're going to be testing some lithium iron phosphate prismatic battery cells. So we have ordered a whole bunch of cells out of China from various manufacturers or resellers. I mean, it's debatable as to whether they are actually the manufacturers, and there's kind of a gray area when you're buying these cells from China. But anyway, we've ordered a whole bunch of cells that we're going to be testing, and the main purpose of that is so that we can write reviews and release some information based on our experience from these, so that people can find that information helpful. Hopefully, if you're in the process of trying to build out a DIY lithium iron phosphate battery and you're not sure whether manufacturers and resellers are trustworthy and whether their products are good and all those sort of things, hopefully this will be helpful for you as you go through that process. So these cells are from a company called Dongguan Huanhuan Technology Company or something. I'll put the name down here. It's a long name. I can't even remember what it is off by heart. But yeah, anyway, this is who these cells are from. And overall, so far, our experience has not been great. They are okay, still good value for money for what you get out of them. When you consider that you can pretty much build a battery for like $600, including the BMS and a Bluetooth functionality, and have a really high capacity and all that sort of stuff. But the quality of the actual cells, the build, the terminals are pretty weak, just cheap aluminum or aluminium and stuff like that. So they're just not great, but they're all right, but still reasonable value for money. But yeah, we thought we would take you through the process of how we're testing them. We've done several tests now. I think we've done like 6 full tests of the cells in series as a full 12-volt battery. And then we've also been doing some individual tests of the cells each. And obviously it was really time consuming. We probably spent the better part of like 2 to 3 weeks actually testing all this stuff out, with the main purpose is that we're going to give a sort of detailed video review of their product and also a written blog review on our website as well. So hopefully that will be helpful for you. When we find manufacturers that have really good cells, we may consider buying a bulk order from China that we will then resell here in the UK and within Europe, with the intention of trying to help people, obviously not having to go through the hassle of trying to import cells from China yourself. So that's really what we're doing with this process. So hopefully this is helpful. I'll hand over to my dad, who is now going to take you through the testing process. Thanks for watching.
Because the area that we normally test in has great temperature variation, we decided to build this booth, insulated booth. It's got polystyrene on 3 sides, a double foam layer on the top and nice mat on the bottom. It's currently sitting on 24 degrees, normally sits at about 25, give or take half a degree or so. But because the door is open now, it's cooling down. There's 2 temperature probes, one to just check what is happening, the other to control the power that goes to the heating pad. So it turns on at about 24.5 and turns off at 25.5. So it sits there between those 2. Here's the battery pack. The cables come out at the bottom. So we just usually keep this door closed. That'll bring it up to a constant 24, 25. And that's the temperature that most cell manufacturers will say that you should test their batteries at or their cells at. To do the actual testing, we've got a low current automatic tester here. It goes up to 185 watts. Currently sitting on 13.3 amps. So that's going to take quite a long time to test the 300 or supposedly 300 amp hour battery. Just to double check, I've also got this Hall sensor with a external display, just to make sure that it is correct. So that's reading 13.3 amps. This is hovering between 13.3, 13.4. So that's good enough. That'll be accurate enough for the test. We'll have a bit of margin for error there. So that's it. We just going to let it all count up, and at the end of that we'll see if the cells are to capacity. These cells are rated at 300 amp hours. Who knows what they're going to be when they finally reach the end. We've set the BMS, so you can't see it here, but behind here is the BMS attached to the 4 cells. So we're running through the BMS. We brought these up to 14.6 volts on the desktop charger, let the cells rest for 4 hours, and then started the test. And we've set the BMS to cut off when the first cell reaches 2.5 volts. We've run a few tests already on these cells, and we know that they're going to come out at about 285 amp hours, so about 5% short of the stated 300 amp hours. And yeah, so we'll just wait and see. One of the cells will shut everything off. It'll come down to 2.5 volts, while the others are still sitting at about 2.8 volts. So in theory, we could get a bit more power, but practically they're all dropping very quickly at that stage as you draw. We're performing a low current or a low C capacity test of a bank of lithium iron phosphate cells. This is the tester that we're running. As you can see, we're approaching 270 amp hours, running at around about 14 amps, 12.2 volts. These have tested out at 285 amp hours before, so we're expecting we're going to reach about the same in this one here. This is a very simple tester. Change the cables to something more substantial. The cells are here in this cabinet, where we maintain a constant temperature of around about 25 degrees centigrade. So it varies between 24.5 and 25. So these cells, the BMS on the side there, as you can see, a heating pad that is run from a very simple device that has temperature probe inside there. So that's the test, nearly complete. 285 amp hours is what we're expecting. According to the BMS, we're running at 14 amps, 11.4 volts left, 5% capacity. The delta is 0.177, which is expected at this stage. It'll increase because basically cell number 3 is dropping voltage quite a bit more than the others now. Not a huge difference yet, but it's going to reach its cutoff at 2.5 volts fairly soon now, and the others will be roughly 2.7 to 2.8. So in theory there'll still be some capacity left in this battery, except that cell number 3 has reached its safety limit. So this is the test itself. According to the tester, we're running at 11.1 volts. The BMS says it's 11.4. That is to be expected. Difference along the wires. 280 amp hours so far, 280.67 to be exact. So we're counting to what we expect is the 285 because we've done this test already. So that is going according to expectations. Well, we hope to get more out of them, but that doesn't look like it's going to be the case. There, the cells sitting in a constant temperature environment, sitting at 25.2 at the moment. And the BMS says, well, it says that they are 25 degrees exactly, which is what we wanted to test at. So that's perfect. Cells sitting inside there. We've dropped below 11 volts at the tester, still sitting at 11.1 at the battery, according to the BMS. So by now, an inverter would have shut down because its safety threshold is 11 volts. So according to the inverter, if we were running it, measuring through a shunt, we would have reached probably, well, the last time we ran this test, we would have reached about 277, 78, just because of the high current draw drops that voltage quite quickly. And as I said, the inverter cuts off at 11 volts. So we're still drawing 14 amps, approaching 282 amp hours, and dropping quite rapidly on cell number 3. It's 2.61 something volts at the moment. that we're expecting within just a few minutes to reach 2.5, at which time the BMS will actually cut it to keep the battery safe. All of the cells have dropped below 2.9 volts now. So the lowest is 2.5, which is the point at which the BMS actually cuts off. As we can see, this is just cut. So this capacity test shows 282.58 amp hours, which is about 3 less than the last test. Disappointing, seeing as the cells are rated at 300 amp hours. So yeah, the BMS has cut the charge, as we can see.